Humanity has always dreamed of reaching beyond Earth, of stepping past the thin blue line of the atmosphere and into the endless darkness filled with stars. From the surface of our planet, space looks silent, beautiful, and almost inviting. Distant planets glow softly in telescope images, wrapped in clouds, ice, or light. But behind this beauty lies a reality far more brutal than most people ever imagine. Space is not neutral. It is hostile. And many worlds beyond Earth are designed, by their very nature, to kill a human being in seconds. The human body is the result of millions of years of evolution under very specific conditions. Earth provides moderate gravity, stable pressure, breathable air, and temperatures that rarely push the limits of survival. Every cell in the human body depends on this balance. Remove even one of these factors, and the system begins to fail. Change all of them at once, as happens on most other planets, and survival becomes impossible. In space, there is no forgiveness for biological weakness. On some planets, the temperature alone is enough to end human life almost instantly. On others, the pressure crushes the body before the brain can register pain. Toxic atmospheres dissolve tissue, while radiation penetrates cells and destroys them at the molecular level. These are not distant theories or science fiction scenarios. They are measurable, documented conditions that exist right now on worlds within our own solar system. Venus, for example, is often called Earth's twin because of its similar size. But stepping onto its surface would be fatal almost immediately. The temperature there reaches nearly 465 degrees Celsius, hot enough to melt lead. The atmospheric pressure is more than 90 times greater than on Earth, enough to crush a human body as if it were made of paper. The clouds above rain sulfuric acid, and the air itself is poisonous. No protective suit humanity has ever built could keep a person alive there for more than a few moments. Mercury offers a different kind of death. With almost no atmosphere to regulate temperature, the planet swings between extremes. During the day, the surface heats up to over 430 degrees Celsius. At night, it drops below -180 degrees. A human exposed to these conditions would suffer catastrophic failure of bodily systems almost instantly, either burned alive or frozen solid, depending on the time of day. The gas giants appear even more alien. Jupiter, the largest planet in the solar system, has no solid surface to stand on. What looks like a calm pattern of clouds from afar is actually a raging storm system with winds exceeding 600 kilometers per hour. As one descends into Jupiter's atmosphere, pressure increases rapidly. Within seconds, the human body would be crushed beyond recognition. Bones would collapse, organs would compress, and survival would be impossible long before reaching any hypothetical surface. Saturn, famous for its rings, presents a different but equally deadly environment. The rings themselves are composed of countless fragments of ice and rock, traveling at enormous speeds. Passing through them would be like flying through a high-velocity minefield. Even the smallest collision could tear apart metal spacecraft, let alone a human body. And like Jupiter, Saturn's atmosphere grows denser and more lethal with every kilometer of descent. The ice giants, Uranus and Neptune, are among the coldest places in the solar system, but cold is not their only threat. Their atmospheres are filled with methane and other gases toxic to human life. Winds on Neptune can exceed 2,000 kilometers per hour, the fastest ever recorded in the solar system. In such an environment, exposed human tissue would freeze, rupture, and be destroyed almost immediately. Even smaller worlds are no safer. Dwarf planets like Pluto or airless moons scattered across the solar system lack the basic protection Earth provides. With no atmosphere to shield against radiation or regulate temperature, the human body would be exposed to lethal cosmic rays and extreme cold. Blood would begin to boil at low pressure, while tissues would freeze and crack. Survival without heavy protection would last only seconds. Beyond our solar system lie exoplanets, worlds orbiting distant stars. Many of them are far more extreme than anything close to Earth. Some are so close to their stars that their surfaces are oceans of molten rock. Others are locked in eternal storms, with chemical compositions that dissolve metal and flesh alike. A human transported to one of these planets would not experience a slow death. It would be immediate, violent, and unavoidable. This contrast reveals a simple truth: humans are fragile. Our intelligence allows us to explore the universe, but our biology ties us to Earth. Spacesuits, spacecraft, and technology offer temporary protection, but they all have limits. Pressure, heat, radiation, and chemistry eventually overcome even the most advanced designs. Space does not adapt to us. We must adapt to it, and in most places, adaptation is impossible. Yet despite this danger, humanity continues to look outward. Telescopes scan the skies. Probes are sent across billions of kilometers. Scientists search for habitable worlds, even as they catalog countless planets that would kill us instantly. The universe invites curiosity, but it demands respect. Beauty and danger exist side by side, inseparable. This documentary explores the most lethal planets known to science, worlds where a human would die in seconds. From the burning surface of Venus to the crushing depths of gas giants and the frozen storms of distant exoplanets, each chapter reveals how unforgiving the cosmos truly is. These are not imagined horrors, but real environments governed by physics and chemistry. The journey begins here. As we move from planet to planet, one truth becomes clear: life on Earth is not the rule of the universe, it is the exception. Beyond our world, survival is not guaranteed, and in many places, it is not even possible. One step onto the wrong planet, one unprotected moment, and the universe reminds us how small and how vulnerable we truly are. From a distance, Venus looks almost peaceful. Wrapped in thick, pale clouds, it shines brightly in the night sky, earning the name, the morning star, or the evening star. For centuries, astronomers imagined it as a lush, ocean-covered world, perhaps even Earth's closest relative in terms of habitability. But the truth is far more horrifying. Venus is not a sister planet to Earth. It is a warning. If a human were somehow transported to the surface of Venus, death would not come slowly. It would not be dramatic in the way movies portray it. It would be immediate, mechanical, and absolute. Within seconds, the human body would be overwhelmed by forces it was never meant to endure. The first and most brutal threat is pressure. Venus's atmosphere is incredibly dense, over 90 times thicker than Earth's at sea level. This means that standing on Venus is equivalent to being nearly 1 kilometer underwater on Earth. But unlike water, Venus's atmosphere is made of crushing gases that press in from every direction at once. Human lungs would collapse instantly. The rib cage would compress. Blood vessels would fail. Even before the brain could fully process what was happening, the body would be fatally damaged. Then comes the heat. The surface temperature of Venus averages around 465 degrees Celsius. This is hot enough to melt lead, deform steel, and destroy electronics designed for space exploration. At this temperature, exposed human tissue would not burn, it would begin to chemically break down. Water inside the body would flash into vapor. Proteins would unravel. Cells would die almost instantly. There would be no chance for pain to fully register. The nervous system would shut down before a scream could form. Unlike Earth, Venus does not cool down at night. The planet rotates slowly, and its thick atmosphere traps heat with extreme efficiency. This runaway greenhouse effect has turned Venus into a planetary furnace. The heat is constant, relentless, and inescapable. There is no shade, no relief, no moment of safety anywhere on the surface. The air itself is lethal. Venus's atmosphere is composed mostly of carbon dioxide, with clouds of sulfuric acid floating high above. Breathing this air is impossible. Inhaling even a small amount would cause immediate chemical burns to the lungs and airways. But in reality, the pressure and heat would kill a human long before suffocation became the main concern. Even technology struggles to survive on Venus. Soviet Venera landers, the only spacecraft to ever transmit images from the planet's surface, lasted minutes at best before being destroyed. Their metal hulls softened. Their electronics overheated. Their internal systems failed one by one. If machines built specifically to endure space cannot survive on Venus, the human body has no chance at all. The ground beneath Venus's clouds is equally hostile. The surface is covered in volcanic plains, crushed rock, and hardened lava flows stretching for thousands of kilometers. Venus is geologically active, with evidence of massive volcanic eruptions that may still occur today. Standing on such a surface would be like standing inside an industrial furnace, surrounded by pressure strong enough to flatten steel structures over time. There is another, quieter killer on Venus: chemistry. Sulfur compounds in the atmosphere corrode materials relentlessly. Over time, they eat away at metals, seals, and protective layers. Any suit designed to protect a human would be chemically attacked from the moment it entered the atmosphere. Even if heat and pressure were somehow controlled, corrosion would eventually breach every defense. Some scientists have speculated about life existing high in Venus's atmosphere, where temperatures and pressures are closer to Earth-like conditions. But this zone exists far above the surface, suspended within acidic clouds. Even there, survival for humans would be extremely limited and entirely dependent on artificial structures. The surface itself remains completely uninhabitable, a place where life, as we know it, cannot exist. Venus serves as a powerful example of how similar beginnings can lead to radically different outcomes. Billions of years ago, Venus may have had water, oceans, and a climate not unlike Earth's. But subtle differences in distance from the Sun and atmospheric composition triggered a catastrophic transformation. The planet overheated, its oceans evaporated, and its atmosphere thickened into a suffocating blanket of carbon dioxide. For humanity, Venus is not a destination, it is a lesson. It shows how fragile habitability is, and how easily a planet can cross the line from life-supporting to instantly lethal. One step onto Venus is not exploration, it is annihilation. In the context of this documentary, Venus represents the most extreme version of a terrestrial planet gone wrong. It has solid ground, gravity similar to Earth, and a familiar size. And yet, it is one of the most hostile environments in the solar system. It proves that familiarity can be deceptive, and that danger does not always come from alien shapes or distant stars. A human on Venus would not die heroically. There would be no final moments of reflection, no time to admire the landscape. Death would occur in seconds through crushing pressure, overwhelming heat, and toxic air acting simultaneously. Venus does not allow visitors. It erases them. As we continue this journey through deadly worlds, Venus stands as the closest reminder to home, and the clearest demonstration that Earth's safety is rare. The line between life and instant death in the universe is thin. On Venus, that line has already been crossed. Mercury is the closest planet to the Sun, a small, silent world scorched by light and stripped nearly bare by gravity and heat. From afar, it looks simple and lifeless, just a cratered sphere drifting endlessly through space. But this simplicity hides one of the most extreme environments in the solar system. Mercury does not kill through pressure or poison. It kills through exposure. Here, survival is measured not in minutes, but in moments. Unlike Earth, Mercury has almost no atmosphere. What little gas surrounds the planet is so thin it cannot trap heat, block radiation, or soften the sun's relentless energy. As a result, Mercury experiences the most dramatic temperature extremes known on any planet. On its summit side, the surface temperature can rise above 430 degrees Celsius. On the dark side, it can plunge below -180 degrees. No biological system can adapt to changes this violent. If a human were placed on Mercury's surface during the day, the effect would be immediate. Without an atmosphere to filter sunlight, solar radiation would strike the body directly. Skin would burn almost instantly. The heat would penetrate clothing, bone, and tissue within seconds. Water inside the body would begin to boil, expanding rapidly and rupturing cells. Even before heat alone became fatal, radiation damage would begin to destroy DNA at a molecular level. There would be no air to breathe. The lungs would draw in nothing but vacuum. Within seconds, oxygen deprivation would lead to loss of consciousness. But suffocation would not be the primary cause of death. The combination of extreme heat and radiation would shut down the nervous system before the brain could process pain or fear. Night offers no mercy. As Mercury rotates away from the Sun, the surface cools rapidly. With no atmosphere to retain warmth, heat escapes into space almost instantly. A human exposed to Mercury's night would experience the opposite extreme. Blood would cool, then freeze. Tissues would stiffen and crack. Cellular structures would collapse as ice crystals formed inside them. This process would happen faster than the human body could respond. The planet's rotation makes the situation even more dangerous. A single day on Mercury lasts nearly 176 Earth days. This means regions remain in constant sunlight or darkness for months at a time. There is no regular cycle of warmth and cooling as on Earth. Instead, the planet is locked into prolonged periods of scorching heat and deadly cold. Any human presence would be trapped in one extreme or the other. Mercury's surface itself adds another layer of danger. It is covered in impact craters, jagged rock formations, and vast plains of ancient lava. With gravity only about 1/3 of Earth's, movement would feel strange and unstable. A simple fall could send a person drifting or crashing into sharp terrain. Without protective equipment, even minor injuries would be fatal due to the lack of air and extreme conditions. Radiation is one of Mercury's most underestimated threats. Being so close to the Sun, the planet is constantly bombarded by high-energy particles. On Earth, the magnetic field and atmosphere shield life from most of this radiation. Mercury has only a weak magnetic field and almost no atmospheric protection. A human standing on its surface would absorb dangerous doses of radiation in seconds, leading to rapid cellular damage and organ failure. Even advanced technology struggles here. Spacecraft orbiting Mercury must be built with extreme heat resistance on one side and insulation on the other. They are carefully oriented to avoid overheating or freezing. If machines require such precision to survive, the human body stands no chance without constant, active protection. Some areas near Mercury's poles contain permanently shadowed craters where temperatures remain extremely low. Scientists believe water ice may exist there, preserved in darkness for billions of years. But these regions are no refuge. The cold is absolute, the darkness unbroken, and the environment just as lethal as the sunlit plains. Cold on Mercury is not gentle, it is total. Mercury demonstrates a fundamental truth about space. Atmosphere is life. Without it, planets become hostile landscapes of extremes. Heat and cold rule without balance. Radiation strikes without resistance. Time itself becomes an enemy, stretching dangerous conditions into endless durations. In this sense, Mercury is not dramatic like Venus or massive like Jupiter. It is brutally honest. It offers no illusion of safety, no deceptive clouds or gentle glow. It is simply a world where biology fails almost immediately. For humans, Mercury represents exposure at its purest form. Stand in the sunlight, and you burn. Step into darkness, and you freeze. Breathe, and there is nothing there. Every second on Mercury is a fight the human body cannot win. As this journey continues, Mercury reminds us that danger in the universe does not always come from violence or chaos. Sometimes it comes from emptiness, from silence, from a planet that offers nothing, no air, no protection, no mercy. On Mercury, life does not struggle. It ends. Jupiter is not a planet in the familiar sense. It has no solid ground, no surface to stand on, no stable boundary between sky and land. From a distance, it appears majestic, bands of color wrapped around the massive sphere, crowned by storms larger than Earth itself. But this beauty hides one of the most violent environments in the solar system. Jupiter does not burn or freeze a human to death first. It crushes. Jupiter is a gas giant, composed almost entirely of hydrogen and helium. What looks like a surface is only the upper layer of an atmosphere thousands of kilometers deep. If a human were somehow placed at the top of Jupiter's cloud layer, there would be no moment of safety. Gravity, more than twice as strong as Earth's, would immediately begin pulling the body downward. As the descent begins, pressure increases with terrifying speed, Every kilometer deeper multiplies the force acting on the body. Lungs would collapse almost instantly. Air trapped inside the body would be compressed violently. Blood vessels would rupture. Bones would begin to deform. The human body is not built to withstand this kind of compression, and within seconds, survival would be impossible. The winds would offer no mercy. Jupiter's atmosphere is in constant motion, with jet streams reaching speeds over 600 kilometers per hour. These winds do not simply push, they tear. A human body, even inside protective gear, would be ripped apart by turbulence long before reaching deeper layers. Orientation would be lost instantly. There would be no up or down, only endless acceleration into chaos. Then comes the temperature. While the upper clouds of Jupiter are extremely cold, deeper layers grow hotter as pressure increases. The heat does not come from the Sun, but from Jupiter itself. The planet is still releasing energy left over from its formation. As one descends, temperatures rise to thousands of degrees Celsius. At these levels, matter behaves differently. Flesh would not burn, it would be destroyed at the atomic level. There is no moment where the descent stops. No solid ground waits below. Instead, Jupiter's atmosphere gradually transitions into a dense, superheated fluid and then into something more like liquid hydrogen. The human body would be crushed long before reaching these depths, reduced to a compressed mass under unimaginable force. Jupiter's most famous feature, the Great Red Spot, illustrates the scale of violence on this planet. This storm has raged for centuries and is larger than Earth itself. Wind speeds within it exceed anything recorded on our planet. A human caught in such a storm would not experience a struggle. The forces involved are so extreme that disintegration would be immediate. Radiation adds another layer of death. Jupiter possesses the strongest magnetic field of any planet in the solar system. This field traps vast amounts of charged particles, creating radiation belts far more intense than those surrounding Earth. A human exposed to this radiation would receive a lethal dose in minutes, even without descending into the atmosphere. Electronics fail here. Cells break apart. DNA is destroyed. Even spacecraft struggle to survive Jupiter's environment. Probes sent into its atmosphere, such as the Galileo probe, were designed for one-way missions. They transmitted data for less than an hour before being crushed and destroyed. Their metal shells buckled. Their instruments failed. If machines built specifically for this purpose cannot survive, the human body has no chance. Jupiter's gravity also poses a threat from afar. Approaching the planet requires precise calculations. A small error in trajectory could result in a spacecraft being pulled in uncontrollably, accelerating to fatal speeds. There is no braking once gravity takes over. For a human, this would mean falling endlessly into a world with no surface and no escape. Unlike Venus or Mercury, Jupiter does not kill in a familiar way. There is no ground beneath your feet, no landscape to observe. Death comes through overwhelming force, pressure. Gravity, radiation, and heat acting together. The experience would be disorienting, violent, and final. Jupiter represents a category of worlds that are fundamentally incompatible with human life. They are not broken versions of Earth. They are entirely different kinds of objects, miniature stars that never ignited, massive spheres of gas governed by physics on a scale humans are not meant to endure. In the context of this documentary, Jupiter serves as a reminder that not all planets can be explored by landing. Some can only be observed from a distance. Crossing that boundary is not bravery, it is destruction. A human falling into Jupiter would never reach a bottom. There is no final impact, no surface to collide with. There is only increasing pressure until the body ceases to exist as a recognizable form. Jupiter does not offer a dramatic end. It offers erasure. As we move deeper into the solar system's most dangerous worlds, Jupiter stands as the ultimate example of a planet that cannot be touched. Its beauty is real. Its danger is absolute. And for humans, it is a place where existence ends not with fire or ice, but with crushing inevitability. Saturn is often described as the most beautiful planet in the solar system. Its vast ring system, glowing softly in reflected sunlight, has inspired artists, scientists, and dreamers for generations. From a distance, Saturn looks calm, elegant, almost gentle. But this beauty is an illusion. Beneath it lies a world just as lethal as Jupiter, one that offers death not through chaos alone, but through deception. Like Jupiter, Saturn is a gas giant. It has no solid surface, no place where a human could ever stand. What appears to be a visible edge is merely the top of an atmosphere that extends thousands of kilometers downward. A human approaching Saturn would not land. They would fall. As the descent begins, gravity takes control. Saturn's gravity is slightly weaker than Jupiter's, but still powerful enough to accelerate a falling body relentlessly. Within seconds, atmospheric pressure would begin to rise. Lungs would compress. Breathing would become impossible. The body would be forced inward by invisible weight pressing from all directions. Saturn's atmosphere is composed mostly of hydrogen and helium, mixed with ammonia, methane, and traces of water vapor. This toxic combination offers no oxygen and no protection. Even if pressure were not an issue, inhalation would cause immediate suffocation. But long before oxygen deprivation could take effect, the crushing force of the atmosphere would end all biological function. Winds on Saturn are among the fastest in the solar system. At the equator, wind speeds can exceed 1,800 kilometers per hour. These winds do not merely push objects, they tear them apart. A human body, even encased in a protective suit, would be subjected to violent turbulence that would twist, disorient, and destroy it within moments. As with Jupiter, temperature increases rapidly with depth. The upper cloud layers are cold, but descending further reveals intense internal heat. Saturn radiates more energy than it receives from the Sun, a remnant of its formation. Deeper layers reach temperatures capable of destroying any known material. Human tissue would not burn in a conventional sense. It would be broken down by pressure and heat acting simultaneously. There is no point of stabilization, no plateau where conditions pause. Pressure and temperature increase continuously, creating an environment where matter itself changes state. Hydrogen begins to behave like a liquid metal. In such conditions, the concept of a human body loses all meaning. Saturn's rings add another layer of danger. From afar, they look smooth and delicate. In reality, they are composed of countless fragments of ice and rock, ranging from tiny grains to objects the size of mountains. These fragments orbit Saturn at tremendous speeds. Passing through the rings would be like flying through a dense field of high-velocity projectiles. Even a small collision could destroy a spacecraft instantly. A human body would be shredded without resistance. The rings also create a false sense of safety. Their graceful structure masks the violent forces that keep them in place. Gravity, collisions, and constant motion define this region. Nothing remains still. Nothing is safe. Saturn's magnetic field introduces yet another threat. While weaker than Jupiter's, it still traps charged particles that create radiation belts capable of damaging biological tissue. Prolonged exposure would lead to rapid cellular damage and organ failure. Combined with the planet's other hazards, radiation ensures that even indirect contact with Saturn is dangerous. Even Saturn's moons, often discussed as potential targets for exploration, exist within this hostile environment. Tidal forces, radiation, and extreme cold shape their surfaces. While some may harbor subsurface oceans, they are protected only by thick layers of ice and exist far from any conditions suitable for humans without massive technological support. Saturn represents a different kind of death than Jupiter. Where Jupiter is overwhelming and violent, Saturn is deceptively graceful. Its danger is quieter, hidden behind symmetry and light. But the outcome is the same. A human entering Saturn's domain would not survive. In the context of this documentary, Saturn reminds us that beauty in the universe does not imply safety. The most visually stunning worlds can also be the most deadly. What looks peaceful from afar may be governed by forces beyond human endurance. A human falling into Saturn would never see a surface, never reach a destination. There would be no final impact, no dramatic end. Only increasing pressure, rising heat, and eventual destruction. Saturn does not attack. It simply allows gravity and physics to do their work. As we continue exploring the deadliest planets known to science, Saturn stands as a warning. Admiration can be dangerous. In the universe, elegance often hides annihilation. And on Saturn, death is as inevitable as the planet's silent, eternal rings. Far beyond the orbit of Saturn lie two worlds that seem quiet and distant, glowing faintly blue in the darkness of space. Uranus and Neptune are often called the ice giants, and at first glance they appear calm, cold, and almost serene. But this calm is deceptive. These planets represent some of the most hostile environments ever discovered, places where cold, pressure, and wind combine to destroy a human body with ruthless efficiency. Uranus and Neptune are composed primarily of hydrogen, helium, and so-called ices, such as water, ammonia, and methane. These substances do not exist as familiar solids here. Under immense pressure, they form dense, superheated fluids that behave nothing like ice on Earth. There is no solid surface. Like Jupiter and Saturn, these planets offer nothing to stand on, only endless descent. The cold is the first illusion. While the upper atmosphere of Uranus and Neptune is indeed frigid, with temperatures dropping below -220 degrees Celsius, cold alone is not what makes these planets deadly. It is the combination of cold, pressure, and motion that turns them into executioners. If a human were exposed to the upper atmosphere of either planet, heat would be stripped from the body almost instantly. Skin would freeze. Blood would thicken. Muscles would lock as cellular processes shut down. Frostbite would occur in seconds, not minutes. But freezing would not be the final cause of death. As gravity pulls the body downward, pressure increases rapidly. Lungs would collapse. Gas trapped in the body would compress violently. Organs would deform under forces they were never designed to withstand. The descent would be disorienting, with no visual reference point and no sense of direction. Neptune, in particular, is infamous for its winds. It holds the record for the fastest winds in the solar system, with speeds exceeding 2,000 kilometers per hour. These winds do not merely blow, they shred. A human body, even within protective equipment, would be torn apart by sheer forces almost immediately. Flesh, bone, and metal alike would be subjected to extreme stress. Uranus presents a different but equally lethal scenario. Its axial tilt is extreme, causing one hemisphere to face the sun for decades while the other remains in darkness. This creates long-lasting atmospheric imbalances that drive powerful storms beneath the clouds. A human entering this environment would be caught in unpredictable currents, pulled in multiple directions at once. Temperature increases with depth on both planets. While the outer layers are cold, deeper regions become increasingly hot due to internal heat and compression. Eventually, temperatures reach levels that destroy molecular structures. Any remaining trace of biological matter would be erased. The atmospheres of Uranus and Neptune are also chemically hostile. Methane gives these planets their blue color, but it is deadly to humans. Ammonia and other compounds further ensure that breathing is impossible. Chemical exposure would cause immediate damage to lungs and tissues, even if pressure and temperature were somehow controlled. Radiation adds another invisible threat. Although weaker than Jupiter's radiation belts, both planets still expose incoming objects to high-energy particles. Over time, this radiation damages cells and DNA, contributing to rapid biological failure. Even robotic exploration of Uranus and Neptune has been limited. The vast distance from Earth, combined with extreme conditions, makes sustained missions difficult. No probe has ever entered Neptune's atmosphere for extended study. The risks are too great, the environment too destructive. For humans, these ice giants are completely inaccessible. There is no region of stability, no altitude where conditions briefly resemble anything survivable. Every layer of their atmospheres is hostile in a different way. Cold gives way to pressure. Pressure gives way to heat. Wind tears apart anything that tries to exist within it. In the broader story of this documentary, Uranus and Neptune represent the outer limits of human reach within the solar system. They are reminders that distance alone does not make a world deadly. Physics does. These planets exist in near total darkness, far from the sun's warmth, yet they remain violent and active. Their storms rage unseen, their winds howl through layers of gas and fluid ice, and their interiors churn with energy beyond human comprehension. A human entering Uranus or Neptune would not experience a single, clear cause of death. It would be a cascade, freezing, crushing, tearing, and overheating happening almost simultaneously. Survival would not be measured in minutes or even seconds. It would end before the mind could understand what was happening. As we move farther from the sun and deeper into this journey, one truth becomes unavoidable. The universe does not grow gentler with distance. On Uranus and Neptune, cold does not mean calm. It means destruction, silent, efficient, and absolute. At first glance, dwarf planets seem less threatening than giants like Jupiter or Saturn. They are small, distant, and quiet, drifting on the edge of the solar system. Worlds such as Pluto, Eris, Haumea, and Ceres do not dominate their surroundings with massive gravity or violent storms. But this apparent harmlessness is misleading. These worlds may be small, but for humans, they are just as deadly. The greatest danger of dwarf planets is not overwhelming force, it is exposure. Most of these worlds lack a true atmosphere. Without this protective layer, there is nothing to regulate temperature, block radiation, or provide breathable air. A human placed on the surface of a dwarf planet would be exposed directly to the vacuum of space. Within seconds, the lack of pressure would cause bodily fluids to begin boiling at normal body temperature. Saliva, moisture in the eyes, and fluids in the lungs would vaporize. The lungs would collapse. Oxygen would leave the bloodstream rapidly, leading to loss of consciousness. Without immediate protection, survival would last only moments. Cold follows quickly. Dwarf planets exist far from the sun, where temperatures are unimaginably low. On Pluto, surface temperatures can fall below -220 degrees Celsius. At these extremes, heat leaves the human body almost instantly. Skin freezes. Blood thickens. Tissues stiffen and crack as ice crystals form within cells. The process is fast and irreversible. Radiation is another silent killer. On Earth, the atmosphere and magnetic field protect life from cosmic rays and solar radiation. Dwarf planets offer no such shield. High-energy particles strike the surface constantly. A human exposed to this radiation would suffer severe cellular damage in a very short time. DNA strands would break. Cells would fail to repair themselves. Even if freezing and suffocation were somehow avoided, radiation would ensure death. Low gravity creates its own hazards. On dwarf planets, gravity is only a fraction of Earth's. Movement would feel unnatural and difficult to control. A small jump could send a person drifting dangerously high. A fall, even from a short height, could result in serious injury. With no atmosphere and no medical support, even minor trauma would be fatal. The surface itself is hostile. Many dwarf planets are covered in frozen nitrogen, methane, or water ice as hard as rock. These surfaces are brittle and unpredictable. Cracks, sharp edges, and unstable terrain make movement dangerous. On Pluto, glaciers of nitrogen ice flow slowly across the landscape, reshaping the surface over time. Falling into such terrain would offer no chance of rescue. Some dwarf planets may have subsurface oceans beneath thick layers of ice. While this has fueled scientific curiosity, it offers no hope for human survival. These oceans are buried under kilometers of frozen crust, under pressure and cold far beyond anything humans could endure. The surface remains lethal. Even the act of landing on a dwarf planet is dangerous. With weak gravity and no atmosphere to slow descent, spacecraft must rely entirely on propulsion for landing. A small error could result in impact at fatal speeds. For a human, there would be no margin for error. Dwarf planets also challenge human perception. Their landscapes may appear calm and still, frozen in time. But this stillness hides constant danger. Temperature swings between sunlight and shadow can be extreme. Shadowed regions may never see the sun, remaining in permanent darkness and cold. Stepping into such areas would mean instant freezing. In this documentary, dwarf planets serve as a reminder that size does not determine danger. A planet does not need massive storms or crushing gravity to be lethal. Sometimes, the absence of protection is enough. For humans, these small worlds represent isolation taken to its extreme. There is no air to breathe, no warmth to borrow, no shield against radiation. Every element that supports life on Earth is missing. Survival is not a matter of strength or intelligence. It is simply impossible. A human standing on a dwarf planet would not experience a dramatic end. There would be no fire, no explosion. Death would come quietly, through vacuum, cold, and radiation. The body would freeze and fall still beneath an alien sky, untouched and unnoticed. As we move beyond these small, frozen worlds, the scale of danger changes once again. The next destinations are not just hostile, they are completely foreign. Planets beyond our solar system follow rules we are only beginning to understand. And on many of them, death would come even faster. Beyond the boundaries of our solar system lie planets unlike anything humanity evolved to imagine. These worlds orbit distant stars, shaped by forces that push physics to its limits. They are called exoplanets, and while some may one day support life, many represent environments so extreme that a human would not survive even a single second. On these planets, the rules that govern survival on Earth simply do not apply. Unlike the familiar planets around our Sun, exoplanets come in forms that defy intuition. Some are larger than Jupiter but orbit closer to their stars than Mercury does to the Sun. Others are rocky worlds locked in eternal day and night, their surfaces split between burning heat and endless darkness. For humans, these planets are not just hostile, they are immediately fatal. One of the most dangerous categories is the hot Jupiter. These gas giants orbit so close to their stars that their atmospheres are superheated. Temperatures can exceed 1,000 degrees Celsius. At such levels, molecules break apart, and metal vaporizes. A human approaching a hot Jupiter would be destroyed by heat and radiation long before entering the atmosphere. Protective technology would fail almost instantly. Then there are lava worlds, rocky exoplanets so close to their stars that their surfaces are oceans of molten rock. On these planets, the ground itself is liquid fire. Temperatures are high enough to vaporize water, burn away organic material, and reshape rock in real time. A human transported to such a surface would be incinerated instantly, leaving no trace behind. Some exoplanets are tidally locked, meaning one side always faces the star while the other remains in permanent darkness. On the day side, temperatures soar beyond survivable limits. On the night side, cold reaches absolute extremes. Between these two regions lie violent atmospheric currents, as air rushes constantly from heat to cold. Winds on these planets can reach thousands of kilometers per hour. Any human caught in such an environment would be torn apart by the sheer force of moving air. Atmospheres on exoplanets can be chemically lethal. Scientists have identified worlds with skies rich in sulfur, chlorine, carbon monoxide, or even vaporized rock. Breathing is impossible. Skin contact alone would cause severe chemical burns. In some cases, clouds rain molten glass or iron. On Earth, rain sustains life. On these planets, it kills. Gravity can also be a silent executioner. Some rocky exoplanets are super-Earth, with several times the mass of our planet. Their gravity is far stronger than Earth's. A human standing on such a world would feel their body pulled downward with crushing force. Movement would become impossible. The heart would struggle to pump blood. Bones and joints would suffer constant stress. Over time, or even minutes, organ failure would occur. Radiation exposure is another constant threat. Many exoplanets orbit stars far more active than the Sun. Powerful stellar flares bombard nearby planets with lethal radiation. Without a strong magnetic field or thick atmosphere, a human would absorb fatal doses in seconds. DNA would be destroyed. Cells would fail catastrophically. Some exoplanets may have atmospheres hundreds of times thicker than Earth's. On these worlds, pressure alone would be enough to kill. A human body would be crushed, lungs collapsing and bones deforming under the immense weight of gas above. Even advanced technology would struggle to resist such force. Exoplanets also challenge the idea of time and survival. Many orbit their stars in just a few days. Conditions change rapidly. Tidal forces stretch and compress the planet itself, generating heat and earthquakes on a planetary scale. A human presence would be exposed to constant instability. In this documentary, exoplanets represent the outer edge of danger, not because they are far away, but because they reveal how narrow the conditions for human life truly are. Earth sits in a delicate balance. Move slightly closer to a star, and oceans boil away. Move slightly farther, and everything freezes. Change atmospheric chemistry, and life collapses. For humans, stepping onto most known exoplanets would not be exploration. It would be extinction. There would be no gradual adaptation, no second chances. The environment itself would end life instantly. These worlds remind us that the universe is not designed for us. We are shaped by one planet, under one set of conditions, in one small corner of space. Everywhere else, physics reigns without compromise. As we move toward the final chapters of this journey, the focus shifts inward. After seeing worlds that kill instantly, one question remains: why is the human body so fragile in the face of the cosmos? And can technology ever truly overcome that fragility? After witnessing worlds that burn, freeze, crush, and poison, a deeper question emerges. Why does the human body fail so quickly beyond Earth? Why do seconds matter? The answer lies not in weakness, but in specialization. Humans are not designed for the universe at large. We are designed for one planet, and one planet only. Every system in the human body depends on a narrow range of conditions. Temperature, pressure, gravity, and chemistry must remain within strict limits for life to continue. On Earth, these conditions are stable enough that we rarely think about them.